Alrighty, so we are going to do our presentation on the metric system that we did today in class. So here's a little bit extra if you need to hear it again. The metric system is also called the SI system, or the Système International, because it's used internationally. Scientists all over the world use it to measure distance, volume, mass, and temperature. And what makes the metric system easy for most people is that it's based on multiples of 10. Instead of, like in America, our customary system where we use 12 inches for a foot and 3 feet for a yard, the metric system is always based on multiples of 10. Now remember your notes on page 17, all of these words that are in red should be filled in your notes, making sure that everything that's read in the presentation ends up in your notes. All right, let's talk about the base units that we use for measurement in the metric system. You want to make sure you're filling in the boxes as we go. For measuring length, we use meters. And we abbreviate that with a lowercase m. So if I wanted to say the counter was 20 meters long, I can just write 20 and a lowercase m. And the instrument that we use is a meter stick or a metric ruler. Make sure the ruler is showing you in centimeters or millimeters and not in inches. If we're measuring in grams, our measurement is mass, not weight, which often is confused with mass, and we will do a lesson on the difference between the two soon. But we will be measuring mass with grams, and that symbol is a lowercase g. And we use what we call a balance. Now, a lot of people think that it is a scale, and it's very similar to a scale, but we're going to cross out scale and make sure we talk about balance, because I want to make sure we understand the difference between mass and weight. And when we think weight, we often think scale. So for mass, we want to think balance. And then we have liquid volume. Liquid volume we measure in liters. Now, the symbol, I know you want to think is a lowercase l, but it's actually a capital L. The reason for this is that a lowercase l, like this, is often confused for an I or a number 1. And we want to make sure that we're not confusing our notes, especially if we had bad handwriting. So capital L for liter. And we use a graduated cylinder, which is what you see here in the picture, or a beaker to measure liquid volume. Temperature is measured in degrees Celsius, and we use the degree symbol, the letter C, and we use a thermometer to measure. So these are our base units and the instruments that we use that you're going to see the most often. Now I want to get into beyond the base units. So not everything is a meter or a liter or a gram. Sometimes it's bigger and sometimes it's smaller. So we use what we call prefixes. So all of these here are called prefixes, and we can put them in front of meter, liter, or gram in order to see if something is bigger or smaller. So if anything is going to be bigger than a meter or liter or gram, we use these prefixes here, kilo, hecto, and deca. Anything smaller are down this way, deci, centi, and milli. You can see that a kilometer or a kilogram or a kiloliter is 1,000 times larger than the base unit, whereas the smaller millimeter, milliliter, or milligram is 1/1000th of a meter, liter, or gram. It's much smaller. Now, not all of these prefixes are used all of the time. And in 6th grade science, we're only going to worry about the ones that we use the most, like kilo, centi, and milli. We're going to take those 3 prefixes and add them to the base unit the most often. That's not to say that hecto and deca and deci are not used, but they're just not very commonly used. You're not going to see them a lot written on things or used in measurement. So we want to stick with the ones you're going to see the most often. So we'll stick with kilo, centi, and milli. Let's do a little practice converting between the different sizes. So for example, if I have 1 kilogram and I want to know how many grams that is, take a moment to think. 1 kilogram is how many grams? 1,000. And I want to show you how we figure that out. So if we start with kilo, 1 kilogram, we're up here. we need to get to gram down here. So first we have to decide what direction we're going in. And from kilo to gram, we are moving to the right. And then we need to figure out how many steps we move to the right. 1, 2, 3. 3 steps to the right. The easiest way to do this is to move the decimal the same amount of steps. So if I've got 1 kilogram, I move the decimal 3 times. 1, 2, 3 to the right, and fill in the spaces with my zeros for 1,000 grams. Let's try another one. Same 1 kilogram, but now I want to know how many milligrams that is. Did you guess a million? 1 kilogram is 1 million milligrams. Let's take a look. Again, we want to start with kilo, but this time we're headed all the way down to milli. What direction are we going in? To the right, but how many times? 1, 2, 3, 4, 5, 6. We got to move 6 steps to get from kilo to milli. So we do the same thing with our decimal. If I've got 1 kilogram, I move 1, 2, 3, 4, 5, 6. Fill in my spaces with zeros. And now I've got 1 million milligrams. Let's take one more practice. I've got 1 centimeter. How many meters do I have? This one's a little trickier. I'll give you a moment to think about it. 1 centimeter is 0.01 meters, or 1/100th. So let's take a look. This one's a little bit trickier. Oops. All right. So here, I'm starting with centi. But I want to get to meter. This time I'm moving to the left. Count how many steps. 1, 2. 2 steps to the left. Same with my decimal. 1, 2. Fill in my space with a 0. 0.01 meters. Now, at this point in the lesson today, we watched a video clip called Metric Beats the Inchworm. I have the video up on my website, so you're more than welcome to watch that. We took 3 notes on page 19 up at the very top. 2 notes we wrote down, 1 note we drew from the video. As always, please see Ms. Wiseau if you need any more help.